Yeah, I think it's this mouse. It's MX Master 3, and at that point I think it's just uncleanable because it has this rubberized surface, and it doesn't work very well in that kind of environment. So I want to do some soldering. Maybe I will use also this one. The hot air gun. Maybe, so I can just place it on the side. So I want some of those. These are transopters and PCF 854074, and these are outputs. So I want one of them. And I could also set up a top camera. With my very professional top camera contraption. So this is a lamp with a selfie stick zip tied to the top part, and I use it to mount the phone and use as a camera from the top. And there are also some cables, because it's not very stable. So I'm using those cables to pull it. Too many cables. Okay, so I'm using those cables to just attach it to some leg of this bench, for example. So it's not just drooping over my work. Okay, I can't manage to tie a knot. Okay, this way, and again like that. This should be fairly secure. And now there is also another cable for stabilizing it in other direction. So in here, and I can just clamp that to the tabletop. Yeah, everything should be fairly visible. Well, I will adjust it later. So for now, let's take this. And the camera app. Oh right, I don't even have this set up with this OBS instance. So this should be this. Oh, it's just connecting without any setup. So yeah, this is fine. Now I will attach the phone charger so it doesn't just drain the battery. Now how to adjust it? So this mount, this very professional camera mount, isn't visible. Or just mostly isn't visible. Yeah, that should be fairly fine. In here, in the middle. And I should probably also have some transistors. But I completely don't remember what transistors these were. Wait a minute. And now I don't have documentation in here. Yeah, I will have to check it on the phone, because I don't have access to my private GitLab on this computer. How do I sign out? I see the camera is still working. And sign in to the private account. So this was PCF out and the documentation. Yeah, this one, and download. And I can put it in here, so it should get synchronized. Maybe I will actually documenter, watcher, and it was doc v3. So yeah, let's see. There should be transistors are 2N7002. 2N7002. Do I have those? I should have those. Unless they all got used up. Let's see in my index of materials. It's what was the name again? 2N700. Okay, I don't have yeah, looks like I don't have this one. It's like impossible. Okay, there's nothing in here. Is there really not a single one left? Maybe in here? Oh, maybe. What is this? Right, so it wasn't here. It seems like I didn't have all these catalogs. Now what resistors? And maybe I could also change the title, because it's not a door renovation anymore. It's a soldering. With an L. So yeah, resistors 10k, 10k. It's in here. Actually, maybe I will just do it one by one, so it's less likely to just mess up. I can start from this. Does the dot go... I never know where those IC start. Okay, and here there aren't any dots. I assume that the dot, like this, will it be visible? No, it probably won't focus on that. But you know, there is this kind of dot in one corner, and I never know where should it go, because the outline with silk screen is usually marked with this kind of semicircle. I assume that that the dot should go towards the semicircle, because I believe that the dot marks the first pin, and semicircle, I think it's on the side of the first pin. So yeah, it will be a complete guess, but let's go with that. And I will just put some solder on one of one pad of each of those places, of those spots, and on each pad I will put a component, an IC. Okay, this works. When I was designing these PCBs, I didn't actually check what kind of these are, I believe, called enclosures. You know, just the shape of the components or package. Yeah, I think it's called package. What packages are available for a given component. So I was mostly just using the default one, and it wasn't always the correct one. Like the default one, the default ones usually, well, often weren't actually available that easily for buying. And that's the last one. So now they are all attached in place, but they are not soldered to all of the pads. So now I should do this. And actually maybe first I could double check. If I'm oriented. I've oriented them correctly. So let's see. I see. Actually, not in here. In here, I see a dot, semi-circle. So yeah, it should be like this. So semicircle, it's on the side where the first pin is, and same with the dot. So dot marks the first pin. So it seems like I did orient it correctly. This one. Also, so let's continue in the camera view. It's not in camera view. Can I extend this? Okay. Turn it a bit. So I'm putting the soldering iron on the top of each pin, and then pushing the solder from the bottom, so that I'm sure it's hot all the way through and it's well connected with the pad. Let's see if everything is connected correctly. Yeah, looks like it. So now I can put those resistors, I mean. So those were 10K, and they are R1 to R3 and 28 to 37. R1, okay, so it's these three. And of course all of them fall on the wrong side. Okay, so again I'm gonna put some solder on one of the pads. And now connect the other side. I don't think I've listened to any Korn song. So yeah, I have no idea what they are singing about. And 28 to 35. So this is this row. better. It would be good to not have any twisted transistors, because they wouldn't connect properly. 1, 2, 3. So this is an output board for Raspberry Pi. It's this whole board is based around this IC PCF 854074, and it's just a pin expander, because I'm using so much stuff, so much like different relays and other things like that, that I need a lot of pin expanders. So I've designed this kind of board for pin expanders. So this is just a pin expander. This is RJ1114, I believe. It should be RJ14 or 11. But anyway, it's an RJ connector for connecting those boards easily. And then the main IC PCF 8574, and then a bunch of transceptors for just separating all the wiring in the house from the microcontroller stuff, for safety of the microcontroller, and then a bunch of resistors, transistors for getting correct voltage, and correct amperage for driving all these relays and other stuff. So I think it's able to drive 10 milliamps, I believe, from each of these screw terminals. So yeah, I'm using those to connect to different relays, mostly relays and switches in the house. There is actually the previous generation over there. So there is a board and the wires connecting to different places around the workshop and the garage. Okay, it's too close. That's good. So yeah, I used up all of the terminals, and I still need to connect some more stuff. I need, I believe, 2 more relays. Or no, actually a lot more relays, like 5 maybe. So I need a couple more of these words. Okay, I spilled some water from my bottle. And are they nice and straight? Mostly. So now I can attach the other side. I don't think I will actually finish it today because I don't think I have all of the components. But yeah, so this is done. Done with 10K resistors. And then 330. That should be 4 to 19. And 4 to 19 are... This is 4 to 11. And then 12 to 19, so over here. Okay. Okay, these two could be corrected. And this one. Actually, this is fine. So now from the other side. Okay. And now in here, the bottom row from R12 to R19. SMD components are supposedly harder to solder by hand, but if they are big enough, I don't think it's actually the case, because you don't have to deal with cutting off the excess legs with through hole resistors, for example. And also you don't have to deal with stuff falling out of the holes when you try to solder from the bottom. Okay, so these are so I still need those resistors and the diodes in here, like this row, is not actually required because this is just for testing. It would be nice to have them to see if everything works, but I don't actually have these small diodes, SMP diodes. So R20 is supposed to be 4.7. 4.7k. One of the magic numbers. It always seems like practically everything is 4.7k. It's kind of like with baking. Everything is supposed to be baked at 180 degrees Celsius. Or I don't know, whatever the equivalent is in freedom units. I'm not sure. It is possible that someday I will do a baking stream, but I don't think it will be anytime soon. Oh right, I wanted this. Those small resistors seem to be like slices of bread with butter on them, always falling top side to the bottom. It was actually supposedly the desired result, like desired feature of butter. So when the food wasn't so cheap and abundant, it was preferred, desired that slice of bread would fall the butter side to the floor, so you could just pick it up, scrape the butter from the top, and eat the slice of bread anyway. But I don't know how true is that. Doesn't seem very very logical, because butter I think is much more valuable than just bread. Like you have to spend more resources to make butter. If I were to do a baking stream, it would be definitely on the weekend, so that my father isn't around and I would be alone. because it would feel really awkward to just have him be at my house, and then I have a camera in the kitchen and I'm talking to the camera. Actually, nobody in my close family even knows that I'm streaming. I'm just doing stuff at the workshop. And I don't really share the details. So yeah, now I could do the transistors. These are capacitors. Maybe I will attach this button. This is also for testing, and actually for the diodes, so that I could press the button and check which diodes are turning on, to verify if everything is working. So these are the transistors. Yeah, my hands are also sometimes shaky, like it depends on the day. Sometimes there are days that I couldn't do this. Like, okay, I dropped one. Like there are days when my hands would go like this, so it wouldn't be really suitable. But now, today it's relatively fine. Okay, how many are? One more. Okay. Okay, these are so fine that I don't even see where is the top and the bottom. Okay. So now let's place one of them. And it's with this shaking on some days. On some days, it's not even only with shaking, but just general dexterity, I guess. Like for example, writing on a keyboard. Some days I just write with speed halved, or even more than halved. I just can't write anything. Well, I can't write anything. I can't write anything at the reasonable pace. Okay, this last one is a bit crooked. Let's check that. Okay, that one needs a bit fixing, realignment. Okay, maybe that one I could adjust. And now capacitors. So it should be C1 is 1/10 of a microfarad. What is this? Oh, right. Those buttons. And this is 1/10. And this is 10. So 1/10 should go to the lower spot. This doesn't seem to have top and bottom. Yeah, that's good. And now for the 10 microfarad. What was the direction on this ones? These ones? Minus. I think the marked part goes over here. Because on the picture, right, this, right, on the picture there is this mark over here, so I assume this corresponds to that mark, unless it's stupid and it's just the opposite way. Well, the worst thing it could happen is that it would blow up. And it wouldn't be a lot of blowing up. It doesn't store that much energy. So yeah, now maybe. Okay, let's just solder everything without any testing. because I would have to do some special setup for testing it, and it would be easier to just use it and see if it works then. Also, these IC are through holes because I couldn't find any SMD variety. So I'm just bending out the pins to make it work with this. So yeah, now it goes on like this, and I will have to shorten the legs a bit. Just very slightly, just the ends. And it should go in this orientation. So let's put some solder on one of the pins. Now place that on top. Make sure everything is aligned correctly. Now I can put some solder on the opposite end, opposite corner. So yeah, my advice with doing something like this is to first find the components and then design the PCB. So you don't have to do something stupid like soldering through-hole IC to SMD pads. And now some through-hole stuff. These screw connectors, gold pins, and a socket. So these should go in here in 3 rows. These pins are for choosing the address, because on this IC you can choose the address or rather last 3 bits of the address by supplying the correct voltage like correct voltage, either 1 or 0. So in case of this, either 0 volts or 3.3 volts to these pins, and because of that the last bits of the address would either turn to 1 or 0. And it's very important when you have a lot of these boards. Well, at least when you have multiple of these boards connected to one microcontroller. It doesn't even have to be a lot. Okay. Okay, and that one is lost forever. That's what I said earlier about not having to worry about stuff falling out. Are they straight? Yeah. So now let's solder the rest of the pins. Now those screw terminals. This one I will install at the end, and maybe I will even connect them like that. You don't really have to connect them, but I think they look better connected. So one more. One more, and this one is separate. They also tend to not to fall out when they are connected like that, because there is some tension on the sides. And I'm just finishing this board. My fancy pin expander. and then I could chill by playing some Minecraft. This is a pin expander, so I'm using a lot of pins on my Raspberry Pis and other, well, not other microcontrollers, just microcontrollers, because Raspberry Pi is single board computer. But anyway, I'm using a lot of pins on my computing devices, and because of that, I'm using those pin expanders. These are PCF 8574. Yes, be patient. These are 8574, and they are pin expanders, so you can connect a bunch of them to some computing device that supports I2C. And then you have eight more pins to connect to whatever you want to connect. And then I add some transceptors for protection against any kind of I don't know, shorts and stuff like that. Any kind of shorts. And then a bunch of like the resistors, transistors and stuff for getting the right voltage and the right current for driving stuff I want to drive. And then from these screw terminals I'm running wires to different, mostly relays around my house. So I can control the lighting and other stuff like that from a computer. And the uses of Raspberry Pi, there are a bunch of different uses. Well, you first have to have the use and then figure out how to use a Raspberry Pi. It doesn't really go other way around. So for example, you want to, I don't know, measure a temperature or maybe a soil humidity, because you do some farming. So you get those soil humidity sensors, and then you have to connect them to something, and that something is usually either a Raspberry Pi or some kind of microcontroller. Yes, you could use it for your greenhouse. So, for example, you would connect this soil humidity sensor to a Raspberry Pi, and then on Raspberry Pi you write some program. On Raspberry Pi you would write some program to yeah, you need a correct plan. I can write you a very detailed plan. Yeah, so on Raspberry Pi you would write some program that would read that stuff from the sensor and do something with it. So for example, I don't know, give it to a home assistant if you have a home assistant, so you could just see the humidity on your phone or on your computer, or maybe some other kind of local automation. So you could also connect some relay or some I don't know, maybe a motor to also to this Raspberry Pi. So when the humidity is too low, the Raspberry Pi could read that low humidity and then turn on the motor, so it would open some kind of watering system. So yeah, this is, I would consider it done. I will test it some other day. Well, actually I can place it over here. Oh, this is an issue. My perfect oh, so many cables. Okay, so I can unconnect this. My perfect camera mount is in the way. Actually, Agonize, have you seen my perfect camera mount? So this is a lamp, and there is a selfie stick zip tied to it, and in here I have a phone used as a top camera. And this lamp is of course not very stable, so I have this wire tied over there to pull it back like that, and then other wire clamped to the table. So it's stable in two directions. It's a perfect system. Yeah, that's why my speakers are not attached in any way right now, because I used up all of the zip ties. And actually, I could make you a plan right now. So this is my previous plan for the monitor stand, and I can make you a plan. So it will even have a diagram. So you would have a Raspberry Pi, RPI, and then a sensor. So the sensor looks like kind of like this. It has stuff like it goes to the soil, and then you connect it to the Raspberry Pi. And then to the Raspberry Pi you can connect also some other stuff. So here is your plan. Nice plan, right? It's fully descriptive. It's all you need. So, I can actually take that off. because this won't be needed anymore. Yes, attach the stuff to Raspberry Pi. Exactly. There is this stupid over here. There is this stupid using DroidCam text, and you can get rid of it if you pay for this application, but I can't pay for the application because payment doesn't work on my phone. It's I try to click pay and it's just loading screen for like an hour. So let's turn my perfect monitor stand. Yeah, it's in case of this app, you have to pay with Google, like Google Play, and it doesn't work on iOS because I'm using iOS. It's /e/OS, a very confusing name. But yeah, it's a de-Googled phone, so it's kind of understandable that Google stuff doesn't work. But also, I like it, but sometimes it's also kind of annoying. So I don't need this anymore, and this. I don't love Google stuff, including mail. Gmail is trash. Like, have you tried connecting it to an email client? Like, with those graphical email clients, it's not that bad. Like, it could be better, but it's kind of fine. Like with Thunderbird or whatever. But I'm a nerd, so I'm using NBSync, and it's horrible. Other mail providers work much better. But you know, you can get it to work. So I could actually go over to my house to wash my hands because they are quite dusty, like everything in this workshop. And first of all, maybe I will. Yeah, I should clean the surface a bit more. I'm pretty sure it's uncleanable. I would like a mouse that doesn't have any rubberized surface. That's just hard. I wonder how much used mice. Yeah, that's the plural. How much used mice cost? Like some fancy mice. Because sometimes, sadly, the mouses, I think, required. Like, I think that the trackball is probably better for a lot of stuff. Well, let's check it. So yeah. It's G502. That's a lot of money. Like this one is a bit less money. What's the difference between all these like X plus and whatever? Am I confirm you're human? Oh, great. Apparently I'm not a human. Let's use a different browser. G502. Where is used? So, price lowest. Maybe also a category. Yeah, it's that's a lot. It's like $20. Yeah, I'm not definitely not human, according to some websites. So yeah, for now I think I will stick to this one. Yeah, it's cheaper than a new one, but it's still expensive. So I wanted to clean it up a bit. I like this keyboard, and the keycaps are kind of nice. Like they are very compact, very low profile and all, but they also have this kind of a rough surface, like they are textured, and they are hard to clean. Like they pick up all the dirt and stuff, and I have to scrub them with isopropyl alcohol. And after that they are still not perfectly clean. So yeah, that should be enough. Um, and I will go to my house to clean my hands. So